Today we'll lay the groundwork for thermodynamics. And when we come back next time, we'll learn about the first and second laws of thermodynamics. What's going on here? Anyway, to start out with our study of thermodynamics, we're going to talk about work done by gas. Well, by or on gas. So let's think about a balloon. So if I just have a balloon, an uninflated balloon, but maybe I've got it sealed off, there's very little pressure in here. Very low pressure. If I increase the pressure in the balloon by a certain amount, what's going to happen? The balloon is going to inflate. It'll get bigger. As the balloon inflates, we get a higher volume. And as the balloon pushes out on the outside air, we can actually say that it does work on the air outside of it. And the relationship between pressure and work and volume is very simple. Here it is. What we'll say is we'll say that work equals P delta V, where W is work, obviously. P is pressure, we learned about pressure last time, and delta V is the change in volume. Now, when delta V is positive, means we have increasing volume. When that happens, the gas does work on something. Or we could say the work is done by the gas. The gas actually does work. When delta V is negative, means we're losing volume, then the work is done on the gas by something else. So, for a positive change in volume, or an increase in volume, work is done by the gas. For a decrease in volume, or a negative change in volume, work is going to be done on the gas. And that'll come up in your questions today. Now, it's a pretty simple equation, so I'm not going to spend a whole lot of time talking about it, but what I will do is talk a little bit about volume. If we've got delta V, that means change in volume. So the first thing is we're going to assume that you know how to find the volume of some basic things, like probably a cylinder, or maybe a prism, or whatnot. Pretty much, I'm going to assume that you know some basic geometry. And this is really like 8th grade geometry. This isn't even 10th grade, which you may or may not have learned from me. This is basic geometry. Can you find volume? If you can't find volume of basic shapes, basic solids, you're sitting in front of a computer. Look up some formulas if you don't know them. Okay? But I want to talk briefly about the most commonly talked about situation with these sort of problems, and that's where we'll have some sort of cylinder with a piston, and that's just some like solid object here. I don't know why I'm coloring this in instead of just doing a fill, but I've started, so I'll finish. Just gonna make my brush bigger. Not too big. Still too big. There we go. Whee. That's fun. Okay. Anyway. Our most common situations will have a piston, and they'll probably give you pressure, just some number, and maybe you're looking for work, or maybe vice versa. Maybe they gave you work and you're looking for pressure, and they'll say, okay, the piston moved some distance. Maybe they'll give you the radius of the cylinder. 5 meters, who knows. Okay, and then they'll say that the pressure causes the piston to move, maybe it causes it to move up, so it's up here now, some number of meters, 2 meters up. Okay, and we want the work, so work just equals P delta V. Well, we don't actually need to find this volume and then the whole volume, right? We want the change in volume. Well, the change in volume is just going to be this much. The volume of the imaginary cylinder that goes from where the piston was at first to where the piston is now. Now we could instead find, like I said, this whole part where it was to start, and then the whole thing, and then subtract, or like we could just find this. So what we would do here, this is the volume of a cylinder, so volume of a cylinder is just pi r squared h. We know r, so it would be pi times 5 squared, and the height in this case would be how far it moved times 2 meters. So we'll end up getting 50 pi, which is 150 something cubic meters. So now we know delta V. Now, this isn't always going to work, as not every single problem will be about a piston. Sometimes they'll actually give you the two volumes, and remember, delta V means VF minus VI. My writing pad is really acting funny right now, as you can tell, I think. But yeah, VF minus VI. So this should be pretty easy. You are going to have work out of the book today. So there's that. I will have the solutions that I'll let you look at so that you'll have some instant feedback you can get. But